Or
That's
live.
a circle.
Of course it's a circle. It's in 3 space.
Viewed edgewise, all right? So let's consider the magnetic field that we get from a loop wire, right? And because in any other position, this calculation is going to be difficult. I'm going to calculate the magnetic field on the axis, all right? For a loop of wire of radius r carrying current I. And this time around, I'm going to use the this form of Biot-Savart law, right? What we need to do is to integrate along the length of the wire. Actually, there is a dV dV over here, all right? And I've got a current density again. And what I'm going to do is do the integral over the, I'm going to take my wire to be infinitesimally thick. And I'm going to just go ahead and do the integral. And that integral of J over the area of the wire, cross-sectional area of the wire, is just the current. So I can rewrite this like this. And do something that's not customarily done, which is to put a vector on that, all right? And I've lost actually the third dimension. I did the integral over dv prime in 2 dimensions. So I'm going to put over the length of the wire. What I'm actually going to do, put the vector over the whole thing. Indicate that I had a current density that was running along the wire. IDL. All right? And in physics 2, the way that you saw this written was 1 over C I dl cross r minus r prime. I think you saw it written like that. Okay? What we're going to do here now is do that B integral. So if we take a look at this situation here, my cross product, this r minus r prime, is the distance from here to there. So that's r minus r prime. Okay? Actually, it's a vector that points in that direction, r minus r prime. Okay? So it points from the point at which the field is being generated to the point where we observe the field. Okay? And then my direction of my magnetic field is going to be given by dl cross r minus r prime. And let's say here I'll take IDL pointing into the board at this point here, right? Into the board here. And so that's the first thing, DL. Cross r minus r prime, that guy there, is going to give me a magnetic, DL, cross r minus r prime, gives me a magnetic field pointing in a direction that I didn't want it to point in. What did I do wrong?
No, that is right. It's just, it's at the top is that direction. That's the direction at the top.
Yes, I know.
And that's the direction it should be.
It should be pointing that way.
Yeah.
No.
Because then you'd have a net.
IDL.
You lose the net.
IDL cross R, no. R minus R prime gives me a D vector pointing like that. And I want it to go the other way.
Why the other way?
No, that's the way it goes. According to Ohanian has it as that, and it cancels. The net cancels. Because isn't the
Oh,
E field
yes,
the one that goes
works.
that way?
It's good. That's the way it should point. Never mind.
Yeah, the E field from a ring of charge points the other way, doesn't it?
Now, okay, so the other thing that I've got to realize is because I've got an equal point over here on this side, the field from this side is going to point like that. Okay? those two are going to cancel in the horizontal plane, and so my field is just going to be that, right? So all I want to do is find the field in the z direction here, right? And if I want the field in the z direction, then I can rewrite this, because I'm only concerned about the z direction, as z hat. The cross product is gone. That's gone. Actually, that's been gone. Z. Z. And here, I can just rewrite this as r squared plus z squared to the 3/2. And one of my z's over r squared plus z squared to the 3/2 is the component along the z direction. And because I'm adding two of those, no. I'm only concerned with the z component from this guy here, and then I'm going to integrate over the length of the wire, right? So the total magnetic field along the z direction, dz, is dz integrated over all the sources, right? Integral dl, integral dl, and z's unimportant here. The integral over dl is just 2 pi capital R. So I end up with 2 pi r I z over r squared plus z squared to the 3/2 over c. Let me check to see whether I did that right.
You had the wrong term for in the bottom. Too.
I need, oh, it's not z here. I need to find the component. What did you say?
It was r squared plus z squared on the bottom of dB.
Turn this into, this should have been 3/2 down here. But I'll turn this
No, it's 3 because that's.
So 3 and then it
It's
cancels.
r
into three.
hat,
Then you have the square on the bottom.
and down here it is squared. All right. Now I've just got unit vectors on the top, right? And this, well, actually what I had written here was okay, I think. R squared plus z squared, just the way it is. No square root because this is squared here, all right? And then I only want the z component now. And the z component is going to be the bigger r is, the bigger z component is. So it's going to be actually r over that distance as a distance. So that should be 3/2 there. That's what I think. And then I do the integral of dl and I get 2 pi r. And Camera off.
okay.